So welcome students. In this question, you're given that you have a point 1 comma 0. You have the curve y is equal to tan of tan inverse x. It's nothing but y is equal to x. Tan and tan inverse gets cancelled. Y is equal to tan of tan inverse x is y is equal to x. Now you're given that you have a circle which passes through 1 comma 0 and touches the curve y is equal to tan of tan inverse x. You are asked to find the locus of the center of such circles. What is the locus of the center of such circles? So let ph comma k be the point on the locus. So if ph comma k is a point on the locus, you will have a circle with h comma k as center, which passes through 1 comma 0 and touches the circle, touches the line y is equal to tan of tan inverse x. So if a circle touches the line y is equal to tan of tan inverse x, that is nothing but y is equal to x. So this will be the perpendicular distance will be equal to r. The distance from the tangent from the center will be equal to radius, and the distance of this point from 1 comma 0 will also be equal to the radius. That is, the distance of this point from 1 comma 0 is exactly same as the perpendicular distance of this point from the line y is equal to x. So if this is p, if you take 1 comma 0 as s and if you take the perpendicular distance as m, ps will always be equal to pm, which is the basic definition of parabola. The distance of a point from a given point should be same as the distance of that point from a given line. So this p, the locus of p, is a parabola with 1 comma 0 as focus and y is equal to x as directrix. Y is equal to x as directrix. So now you have a parabola which looks like this. You have a parabola which looks like this. That's a locus. Now what are the properties of this parabola? 1 comma 0 is the focus. Y is equal to x is the directrix, that is okay. Next, what is the axis of this parabola? The axis of this parabola is nothing but a line perpendicular to y is equal to x passing through 1 comma 0. So y is equal to x is x minus y is equal to 0. So what is a line which is perpendicular to this? So perpendicular line will be of the form, the slope of this is plus 1. So the perpendicular line will be of the form x plus y is equal to some k. It has to pass through 1 comma 0. So if you substitute 1 comma 0, the k will be equal to 1. So x plus y is equal to 1. So x plus y is equal to 1 is the axis of symmetry. And if you are asked to find the lattice rectum of this. So the lattice rectum of this, so how do you find this? So the distance from the focus onto the directrix is nothing but half of lattice rectum. Lattice rectum is 4a and the distance of focus from the distance of the focus to the directrix is 2a. So if you have x minus y is equal to 0 and if you have the point 1 comma 0, the distance between these two is 1 by root 2. You know the formula. If you have to substitute 1 comma 0 on this line. So 1 minus 0 by root of 1 square plus 1 square is 1 by root 2. This is nothing but 2a. So what is 4a, which is lattice rectum, is nothing but 2 times this, which is equal to root 2. So the lattice rectum of this parabola is root 2. So if you want the focus of this, if you want the vertex of this parabola, so you just need to find the foot of the perpendicular of s on this line y is equal to x, and you have to get the midpoint of this. So if you are asking me to find the vertex of this, I will use the formula for foot of the perpendicular first, okay, and then find SM first. The foot of the perpendicular is nothing but x minus 1 by 1 is equal to y minus 0 by minus 1 is equal to, just need to put this point on this line, on the line x minus y. So minus 1 times, you put 1 comma 0 on this line, which is 1 by a square plus b square is 2. Implies x is equal to this, you have minus 1 by 2 plus 1 by 2, and y is equal to again 1 by 2. That means the foot of the perpendicular is half comma half. So what is the vertex? Vertex is the midpoint of 1 comma 0 and this point. So the vertex is given by 1 by 2 plus 1, 3 by 2 by 2, that is 3 by 4 comma 1 by 2 plus 0, 1 by 2 by 2 is 1 by 4. That is the vertex of this parabola. So in this way you can find different properties of the locus. Thank you.